I was thinking that I will not make the BARC interview course for thermodynamics, but I have got almost, at least 10 comments regarding one simple question, that there is a beaker in which you have ice at minus 20 degrees Celsius and you are heating it. You have to draw the temperature versus time graph, and then you have to draw the specific volume versus time graph. Also, if you close the beaker with a lid, then you have to draw the same graphs and you have to draw it on the same plot to compare. Okay, so this question, it may sound very simple, but it is not that much simple if your fundamentals about the properties of pure substance is immensely strong. Yes, you have to be very clear about all the things. Even if you don't know the values, you have to be clear about the PV plot, TV plot, PT plot, and the PVT surface structure. So don't worry. Now I have brought the BARC Thermodynamics guidance course, and here I have covered firstly the properties of pure substance, and also this question I have taught how to think when these type of questions come, because these type of questions are their favorite question. Also, I have covered piston cylinder type problems, which are the trademark BARC thermodynamics problems. Then I have also said a few words about the Rankine cycle and the relevant, the relevant concepts, okay, relevant to BARC interview. So again, this course is will actually cost you $899, but again there is a fixed amount of stipulated time, that is the next 24 hours. If you can buy it, then it will be a $499 package, $499 course. And if you have already bought a package of heat transfer fluid mechanics and your heat transfer fluid mechanics and strength of materials, in that package the 200 rupees discount was already there. So now if anyone new is buying the package, so you haven't bought any course, but you want to buy the full package again, then there is again a discount of 200. Okay, so actual price of this full package is 899 into 4, but for the next 24 hours it will be 499 into 4 minus 200 for the package only. Okay, so all these offers are valid for next 24 hours, but obviously we want to know that whether I should buy this course or not. For that purpose, here is the sample video. Watch it. What the scenario says is, there is a beaker. There is a beaker with ice at minus 20 degrees Celsius, and it is open to 1 atmospheric pressure. It is open to atmosphere and you are heating it. Now you have to draw first the temperature versus time graph. Okay, and then you have to draw the specific volume versus time graph. Specific volume versus time graph. So first we draw the temperature versus time. See, you have to be very careful here, because you need to understand that there are so many properties. So firstly, what will happen if there is ice and I am if I am just increasing the temperature, I am heating, so the temperature will obviously increase. So firstly it is at minus 20 degree. So you have to tell me that how the temperature will increase. Will it increase like this or a straight line? See, on which thing it will depend? It will depend on the specific heat, right? If the specific heat is more, then for the same heat input, the temperature rise, or I should write it that the delta T, temperature rise, is equal to Q by mCp. So if the specific heat is more, the temperature rise will be lesser. Okay, now actually with the increase in temperature for ice, specific heat rises. Okay, that means if I see that my dt, it should be clear. Okay, so dt should be this one. Okay, so let me write the equations very clearly, right? Okay, that you see my dt by dt, that is the slope time temperature, temperature times slope is equals to q dot, that is the heat rate, by mcp. That we can write easily, that we can write, not m dot, it is okay, because your m, अरे फिर से m dot लिख दिया, mcp. So mcp dt is equals to q dot into dt, this we can know. So now you see, if my cp is increasing with temperature, that means my slope will decrease, right? So it should actually be like this, there should be a downward slope, but we can actually neglect this rise in cp because it is not that much. Oh, yes, it is really not that much, it is like from 2 to 2.3, ऐसा कुछ होता है, ठीक है. Now if it is something like this, then either you can draw it like a decreasing slope or you can draw it like a straight line, okay. So I will draw it like a straight line, but never draw it like a increasing slope, okay. So it is a straight line, it is a straight line. So up until how much it will be a straight line? So we have to understand that it will be 0 degree Celsius, it will be 0 degree Celsius. Then let me again just continue. Then we all very know that there will be a straight line, there will be a straight line, right? There will be a straight line. After that, after this straight line, what will happen? Now it has become water. Now again, for water it is even more, I mean, it is even more complex, the Cp value. First of all, you have to understand that the Cp of water, okay, that the Cp of water is much more than Cp of ice, okay. So we have again two options, we can draw it as a straight line, but if you are drawing it as a straight line, you have to understand that just because Cp of water is more, that means the slope will be less, that means that dt slope will be less, even if you are considering it as a straight line. So it will have a lesser slope like this. So you can see that this is a slope and this is also a slope theta. So this angle is lower, so the slope is decreasing, right? The slope is decreasing. So this you have to understand. But again, for what are actually happening, what actually happens, that your Cp now decreases up to a certain temperature and it goes to a minimum, then it again increases, okay, then it again increases. Or let me just check, okay, actually these are just the variation, okay, these are just the variation and these are just the fact. So I have the fact written with me, but this is actually not that much important, because in the BARC you can draw it as a straight line, okay. But still let me check that for water, the specific heat, uh, for water, we can say that the heat capacity is almost constant, okay, that the heat capacity is almost constant, right, with temperature. But it has a variation. I think the variation is like this, it will go up and it will decrease, it will go up and it will decrease. I think the variation is something like this, okay. Just for the sake of correctness, let me check with Google, okay, Cp of water variation. See, these are just your facts, okay. So there is, I don't always memorize the facts, so let me just check for once. And here what happens, that varies non-linearly with temperature, it is minimum, it is at its minimum of yes, and then increases. So I was right at the first time, okay. So it will be like this, that the curve, the Cp curve, the Cp first decreases and then increases, okay, up to 35 degrees Celsius the Cp decreases and then it will increase. And if it is so, if the Cp is decreasing, you see, then the slope will first increase, it will reach to a maximum and then it will decrease. the slope will have a opposite variation of Cp, because the slope is inversely proportional to Cp. So either you can draw it as a straight line, that is also okay, because the variation is not that much. It is like 4.2, 4.2, from 4.2, then it will go to 4.17, then it will again rise. Okay, so but still it you can give the rise like this, that the first the slope is increasing. Okay, sorry, so either you can draw it like this, or you can draw that the first the slope is increasing, then the slope will decrease. So actual variation will be like this, actual variation will be like this, and this inflection point will be at 35 degrees Celsius. This will be the actual variation, but in BRC again you don't need to draw like that. Okay, you can consider it as a straight line. After that again, if it reaches to 100 degrees Celsius, after that again there will be a plateau, there will be a plateau. Okay, then it actually, I mean, converts to steam, and then again a sharp rise in temperature, or actually, okay, so let me just tell you one more thing, that you see this length of the plateau should be lesser than this length of the plateau. Why? Because you see H HFG, so or H ice water, and here H water to steam, H water to steam. So H water to steam is more than H ice water. If this is more, it needs more heat. That means it will take more time if the heat rate is constant. That is why this length is larger. These are very important facts. After that, actually the steam will vaporize and it will go out of the beaker, but still if we consider that how the steam temperature will change at constant pressure. So at constant pressure again, the steam will have again a higher slope, it will have again a higher slope. It will be almost like the ice, but the specific heat of steam is more than ice. Okay, so it will have a lesser slope than ice but more slope than water. So it will you must have to show a more slope than water. Okay, so this will be the actual graph. Okay, so now let me remove all these things, and now let me draw the variation for specific volume. So for specific volume, what will happen? First, let me draw these kind of lines. These are important. Okay, because you have to show the things clearly. Okay, okay. So for ice, the specific volume will increase almost linearly from a particular value. It will almost increase linearly. Okay, but if they ask that on which property it will depend on the thermal expansion coefficient of the ice. So if I consider that that is not changing much, then it will be like this. Okay, but the moment it reaches to 0 degrees Celsius, now you know from this diagram, your PVT surface, that your volume actually contracts as you are increase the temperature. I am zooming it more, your volume decreases. This is your increasing volume direction, so your volume decreases as you are increasing the temperature, right? It will contract when it will melt. That is the anomalous behavior, okay, for water. That is why